Hello everyone, it's Sajjad again, and today we're going to solve another programming challenge. This is actually the fourth problem in our series, which was supposed to be 100 problems solved. The website would be Leetcode, but this time one of my friends has sent me this problem. So let's just go through it and see what we could get out of it. Okay. Problem 518, coin change 2. You are given an integer array coins representing coins of different denominations and an integer amount representing a total amount of money. Return the number of combinations that make up the amount. The total number of combinations that make up the amount. If the amount of money cannot be made up by any combination of the coins, return 0. So you may assume that you have an infinite number of each kind of coin. The answer is guaranteed to fit into a signed 32-bit integer. Okay, so here basically the inputs, if the amount is 5 and the coins are 1 to 5, we could do it in 4 ways. Either give them one coin with the value of 5, or give them 3 coins, 2 with the value of 2 and 1 with the value of 1, or give them 4 coins, 1, 2 and 3 ones, or give them 5 ones. And there are 4 ways to do this change. Okay. But if the amount is 3 and we only have coins 2, unlimited number of them, still we couldn't make 3 with the only coin 2. Obvious. And if the amount is 10 and the only coin that we have is a type 10 coin, even infinity number of amounts of coin, we only could do 110 with 1 coin. There's only one way to do it. Okay, let's see what the constraints would be. So the number of length of the coins is between 1 and 300. Each coin individually is between 1 and 5,000. All of the values coins are unique, and the amount that we're going to change is between 0 and 5,000. Okay, I think I've got a good sense of what this problem would be. So let's just jump to the solution then. So, based on my experience, this problem is some kind of dynamic programming type of problem. So, if we want to see, we call it change, of amount 5 with coins 1, 2 and 5, how many ways we could change this, then this is how I would approach it. First, we say that we won't use the coin number 1. Then we count how many ways we could do the change with only coins 2 and 5. Then we say we only use one coin number 1. How many change we could do with coins 2 and 5? Then we say we want 2 coins number 1. How many change we could do with coins 2 and 5? 3 coins number 1, 4 coins number 1, and 5 coins number 1. And if we sum all these values together, then obviously we would get the total amounts that we are seeking. So this would be for 1, 0 usages of 1. Then it's like we're solving this problem with 5 for 2 and 5, right? So this means that the coin 1 is not used. We only have 2 types of coins. But if we use one of the coins, then we used 1, so our absolute change has decreased by 1. Now, how many could we do? If we do use 2 ones, then it's not change, it's change. How many could be done? But it's going to be 3. If we use 3 coins, obviously the remainder is 2. So the first parameter is the remainder, and the second is a set of coins that we have. If we use 4 of them, then 1. And last but not least, if we use 5, then we would have something like this. So if we add all of these together, at the end, it's the number of values that we could have. So for change 0 and with the coins 2 and 5, there's only one way, not to use any coins. For the change 1 with coins 2 and 5, there's actually one way to use 2 coins of 2, and that's it. For using 3 coins of 1. Oh, no, sorry. This doesn't have any. So this is saying we're using 4 of 1s. 4 of 1 coins. The remaining amount is 1. We couldn't do anything with these coins to make the change. If we use 3 coins, then there's one way, just use 1 coin of type 2. If we use 2 coins, there won't be any way to do it. If we use only 1 coin, there is one way to use 2 2s. And if we don't use any 1s, then there is actually one way to use just 1 5. And if we sum all of these together, then we would have 4, which, as the problem states here, it's 4. And we got the correct answer. But we have to remember something. Why did I say that in my experience this is a dynamic programming problem? Because if we go, this is a recursion, right? It's a recursive function. If we go deep in, then there might be times that we are calculating something multiple times, and that's not pleasant for us. So to make sure you understand what I mean, let's do this. Let's do a simple implementation with the recursion and show you that this problem won't work with just the recursion. And it's an easy step called memoization. We could use that or use dynamic programming from the bottom up, because memoization does it top down, and we could do dynamic programming from the bottom up to figure out the numbers. Okay. Actually, I'm not going to use this function as my recursive function. I'm going to write another function, which is going to be called number of ways. For example, then I'm going to pass in an amount, as the problem says, the number of coins, because we must know how many coins are left. And I want to pass in another value, which would be coin index. So what does this value mean? It means we used 1, we used 2, we used 3, so on and so forth. Okay, so this is going to return a number, obviously. If the amount or the change or whatever we call it, remainder, the amount is good for now. If the amount is 0, obviously there is always one way to do it. So number of ways. If amount is 0, it's 1. Every recursion needs an endpoint, and here in our case, if the amount is 0, then we're returning 1. If the coin index is greater and or equal than the coins dot length. In this case also we would returns 0 because like this is index 0, index 1, index 2. Now if we say that's the index that we're currently are going to see, we're shortening the array. I'm not going to actually pass the shortened array. What I'm going to do, which I could do it, I'll tell you why I'm not passing the shortened array and I'm passing the coin index instead. So if the coin index is greater than the size of this, so imagine that we're always passing 1 here. The index is 1. This is the same as saying this. So if now we say 3, it means we are out of scope and we don't have any coins. So in that case, obviously it's going to be 0. Okay, so we're going to have a few things that we have to consider. There's a for loop to generate all these sub calls. So the for loops would be like this. Let remainder at the beginning is at the same as the amount. Then as long as the remainder is greater or equal to the amount, we continue. I don't have an increment for this problem at least. So what I'm going to do is decrease an amount from the remainder. First, I'm going to say, okay, the coin index that we are in, so remainder negative equals to, this is equal to remainder minus coins at coin index. So I'm going to decrease the amount here, but I'm not going to do it first. First, I'm going to call the itself once more, and I'm going to have the result, which is initially 0. So if we do know the number of ways that we could make this amount using with the same coins without using, so at the beginning the remainder and the amount are the same, so we say the remainder instead with the coins without using the coin index, then we can just sum them up, right? And each time that we calculated that, we'll decrease the remainder. How much? As the amount, like we're using this coin one more time, calculating it. We're using this coin one more time, recalculating it. But we are increasing the coin index by 1 here to go to the next coin. So the remainder, which is initially the same as the amount, with the same coins, but from like, it's like we're not using it at all. Then for the first time we use it once, we use it twice, we use it 3 times, and so on and so forth. Then we want to return the remainder, the results. Okay. So in the main change function, what we're going to do is number of ways, the amount, we're going to definitely return it. Amounts, coins, and yeah, just get what it returns. So let's run this code for the first time. Okay, so the initial index would be 0. We're starting from coin 0. It's complaining that we should have passed three parameters, but we're passing 2. Okay. So it says that we got 0, but we were expecting 4. Let's see. So if the amount is 0, we have one way. If the coin index is greater or equal than coins dot length, we have nothing. The result starts with 0. Then we start incrementing it by number of ways, which would be decreased by the coin index. So, actually starting from the amount, as long as equal to 0. Yep, that's the problem. As long as the remainder is greater than 0, because we're not going to do the negatives. Let's check it right now. Yes. Okay, let's test the use cases and see if it works. So we passed all the initial test cases that the problem stated. So let's just submit it, and I'm going to show you that we're going to get time limit exceeded because we have recursions overlapping sub recursions, which is an obvious case for dynamic programming. So let's submit it. And we wait. And the result would be waiting more. Yes, time limit exceeded. So it took way too long because we have tons of overlapping states as we imagined. So let's solve this problem. And I know exactly how, with a simple memoization. The trick to memoization is you first solve it with recursion. Then each time that you're going to read the data from the recursion, you check the memory to see if it's been pre-calculated. If it has, then you just read the value from that calculation instead of recalculating it again. So let's just double check the size of the problem once more. As you can see, the size of the problem is the number of coins is 300 and the value of amount is 5,000. So we could have a 2, and this is exactly why I went for having a simple index instead of passing the array, because now I could memoize it. So this is what I'm going to do. First, I'm going to have a number of ways memoized, something like this, and it's going to be a 2-dimensional array. So for let I equals 0 to I 5001 I plus plus, then number of ways memoized is going to be a new array, and for let's say j from 0 2j equals 300, there are at most 300 coins, then let's make it a little more prettier and readable. Then number of ways memoized I dot push -1. So this is the way that we create a two-dimensional array with dimensions 5001 and 301. So here, as I said, we have to do something else. We first go to this part and change the contract of the function and add this number of ways memoized, which is a number, to the contract, and we will pass it here as well. So it would be number of ways memoized. And here, since we have access to this, and it's always called by reference because it's an array, so it would be changed, it's going to be mutatable. Then we would have if this amount for what was the I? It was the remainder, the 5,000. The maximum number was supposed to be 5,000, so the remainder is from 0 to 5,001. And what was the index of ours? The index would be coin index +1, right? We want to see if this value is -1, meaning we have pre-calculated it. If we have pre-calculated it, then if we haven't pre-calculated it, first we calculate and place it in the array, would be remainder coin index +1 equals this, and then use it. Remainder and coin index +1. So all we did was just memoize what we have pre-calculated. Let's make sure we don't have bugs, and it works for its data. Okay, but got 3. Yes, here in calling it, we should have passed number of ways memoized as well. So let's run the code again. Okay, so initially we should have made it equal to an empty array, so we could push stuff on it. Let's run the code once more. And we get all the test cases again. So if we submit it, hopefully this time we would pass all the tests. Yes. And as seen, we get a great, nice success here. So let's wrap it up once more. We said, let's use the name of the functions that we just used to not make it any more confusing than it is. Okay. So the expectation here is that you know the basics of recursions. So what we're doing is we created a function called number of ways. This is the remainder amount that we want to calculate. And we're passing the coins that we could use to do those calculations. Then this is the index of the start of the coins that we are going to use. And the problem itself said that it's going to assure that it's actually unique. So starting from 0, we have all the possible combinations of coins 1, 2, 3. To solve that, we take the coin 1. There are 6 possible outcomes. Either we don't use any ones, we use 1, 1, 2, 3, 4, or 5 ones. If we use 6 ones, as you can see here, then what would happen is we are getting to a value which is negative. Obviously, from here, we couldn't make any more changes. So if we use 0 ones, we have 5 left with these coins starting from 1. So it's 2 and 5. If we use 1 ones, we have 4 amounts to be changed left, and we have 3 coins, but starting from 1, so on and so forth. And this code for the implementation, we use memoization, meaning we created a 2-dimensional array. This is TypeScript, by the way. So we define the type. It's going to be number. One dimension would be the amount needed to be changed, and one dimension would be the index of the coin we're starting from. So first, initially, they're all negative ones. We say, as we said here, the amount we want to change, the coins, starting index, the amount, coins, starting index, and we're always passing this memoized array to it. Then in the number of ways, what we're doing is that if the amount is 0, this is the base of the recursion, we are sure we should return 1. If the index of the coin passes the length of the number of coins that we had, there's no other way to do the change. Then for the other than these 2 base points, we say the result starting from 0, imagine that the remainder is this amount. Then unless the remainder is greater than 0, this semicolon says that we don't have any increment. We could have done it with a while. Taking this, making the while, extracting this outside, and having just one condition. But I did it with a for, and there's no difference in these 2 loops. So if the memoized, which is passed, pre-process the remainder with the next coins, means it's not -1 anymore. We calculate it, remainder, coins, and put it in the memoization. Otherwise, we just add it. It means we have the value and we don't need to calculate it. So we just add it to the results. And use 1 more coin, as we saw here. Use 1 coin, use 1 more coin, and the remainder just decreases. And after we have done that, we return the results. And as we saw, it gives us the perfect answer. So thanks for your time for today. Hope you enjoyed it. We are going to solve more problems in the upcoming days. Stay tuned, like and subscribe if you want more content like this. Bye.